All right, now we have the fall 2021 AMC 10B, problem number 11. A regular hexagon of side length 1 is inscribed in a circle. Okay, let's just draw that, I guess. So we've got a circle. You're going to have a regular hexagon. I guess I'll go about here, come down here, go over there, go up here, and go there. Something like that. Okay, each minor arc of the circle determined by a side of the hexagon is reflected over that side. Well, they say its side length is 1, and the one thing you should know about hexagons is that from the center, if you draw the diagonals, it is 6 equilateral triangles. And since they're equilateral, this side here is 1 and 1 and 1, and you know the radius of the circle is 1. Keep that in mind. Now we're going to take what? We're going to take this part, this segment right here, which is this part above the triangle, and we're going to reflect it over like this. Okay? And like this. 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 Okay. What is the area of the region bounded by these 6 reflected arcs? So they only want the region in here. If you tried to find the region out here, like between these two added up plus these two, it's not up there, and so you would know that you did it wrong. Don't ask me how I know that. They really just want you to find the part inside, which is the obvious interpretation that you should make once you realize it's not those 6 little football shapes going around the outside. So then, how do we get that? Well, first, let's find the area of this little, the combined area of these segments, they're called. And all I'm going to do is take the area of a circle, which is pi r squared. R is 1, so it's pi. And we're going to subtract the hexagon's area. How do you get the area of a hexagon? There's a bunch of different ways. My preferred way for a regular hexagon is 6 times the area formula for an equilateral triangle, which is a small notebook concept. And you definitely want to have this in there. It's going to be s squared root 3 over 4. I normally don't like s, but in this case I've always stuck with it. It's how I originally learned it, and it just works. S is the side length. Since our side length is 1, this is just going to cancel and be nothing. 6 over 4, 6 root 3 over 4. Okay, which is going to be 3 root 3 over 2. Now, that area right there, that is the area of all of the segments combined. All of them combined. We just take the circle minus the hexagon. What's left is all of these circular segments, if you will. So how are we going to get this part in here? Well, now we're going to take the area of the circle and subtract twice that area, right? Because if I have the whole circle and I take this one here, doubles to this one doubles to this one, this one doubles to that, it's just twice that area that we just found. So if I do that, pi minus 2 pi is going to have a minus pi, and negative 2 times a negative is going to become a positive. The 2's will cancel. You will get 3 root 3 minus pi. Answer choice B. And we're going to do problem 12. Now the fall 2021 AMC 10B problem 12. It was also the 12B problem 7. Which of the following conditions is sufficient to guarantee that integers x, y, and z satisfy this equation? I will admit I thought about different ways to approach this. I tried to distribute it. So if you distribute it, you're going to get an x squared plus y squared plus z squared, and then you're going to have minus xy plus yz plus xz. And you can write it like that, and you could say that equals 1. And from there I thought, well, what if I made these roots of an equation? Then I would have the sum of the squares of the roots. I think you can find that in like a 6-degree polynomial maybe. I think I've seen one like that before. You could also have where it's like a cubed, it's like a x minus r, x minus p, x minus q, that whole expression squared. And then you would maybe get something like this, where the roots, I'm sorry, use a different variable, u minus x, u minus y, u minus z, then you might generate the sum of the squares of the roots as one of the coefficients. This is the pairwise product of the roots, and you could maybe do something with that. At the time when I took the test, this was not coming to my mind very cleanly, and I knew that for the sum of the squares I wouldn't just be able to use a cubic polynomial, so I said, there's probably a solution that way. This is a hint. If you guys found one that way, leave it in the comments. It's probably pretty cool. I will pin that comment if it's well explained. Okay, but what I just did at this point is I said, you know what, let's just try some of these out. So I said, I don't know about the x greater than y. This one's weird to me and this one's weird to me. So I said, let's try something like this or this, try to find some way to work through it. So the fact that I can write x equals y minus 1, if I just tried plugging in b and see what I get, y minus 1 minus y is just going to be minus 1. So you're going to get negative x plus, and then you're going to have y squared minus yz, but you know that y is equal to z minus 1. So maybe we can plug this in. Z minus 1 minus z, I get a negative 1, so now you get negative y. Okay, it's kind of okay. Then what? We've got z minus x. I don't have a relationship with z and x. I guess I could make one, because if I replace this y with the z minus 1, then I get z minus 2. So you would basically be able to conclude by substitution that x is z minus 2. Now what would I have? Z minus, so I'd have z minus 2 as the inside part of this expression. So that's going to give me 0, negative 2 is 2 times z. I get plus 2z would equal 1. Now, at this point, I've already got y in terms of z. Let's go ahead and replace it. Z minus 1 plus 2z equals 1. Negative x is z minus 2, so I've got negative z minus 2. I will distribute to get negative z plus 2 minus c plus 1 plus 2z is equal to 1. That's not going to work because the negative z, 2z gives 3 equals 1, and last time I checked, that doesn't work. So that told me this method doesn't work for b. And again, this is probably not the most efficient way. All of the solutions that I'm going to share on the channel are ones that I solved myself. And I will sometimes share another solution, but I will give attribution for that solution to wherever I got it from for that source. And so, yeah, if you don't think that, if you have a faster way, right? I don't know every most efficient way for every single problem on every single test. I just know the way I solved it. And sometimes you're not going to have the most efficient way at your disposal. Maybe it was this when you take the test. You've just got to do it with what you've got. So this is deserted island principle. I couldn't think of the best way, but I'm not going to give up. I'm just going to make it work. I'm going to throw things at it until I get it. So now I'll try this one here. If I let x equal z, I saw this one I tried next because it's kind of nice, right? You get the 0 right here. It just goes away. And so then over here, I could make this x times x minus y times or plus y times y minus x. Well, let's just do it this way. Y times y minus x. And now think about x minus y and y minus x are really the same term if I pull a negative out. So if I pull a negative out of this one, I will get x times x minus y times x minus y. If you didn't know, you can flip any subtraction by taking the negative out. Then that will let me factor out an x minus y, and what you'll have left inside is x minus y equals 1. Where's the equals 1? The same one that was always here. Now what else do we have? We also have that x is equal to y minus 1. So if I put y minus 1 in here, I'm going to get y minus 1 minus y. And that means the y's are going to cancel. You're going to get negative 1. And since it's the same expression, you would have negative 1 times negative 1, which is always 1 for all situations such as this. So this is going to be the answer. Remember, just because we can't think of the best, most genius way, because we've got all these small notebook concepts and so many things to remember, maybe you can't do it in that moment. It slips your mind. But guess what? The clock is ticking. You're going to have to resort to other methods. And that's what I did, and that's the solution that I shared with you. Let's go to the next one. Then we will do the fall 2021 AMC 10B problem 13. A square with side length 3 is inscribed in an isosceles triangle with one side of the square along the base of the triangle. Must be this one. A square with side length 2 must be the other one, has 2 vertices on the other square, the other 2 on the sides of the triangle as shown. We've made sense of it now. What is the area of the triangle? Immediately I want to drop the altitude because I know for isosceles triangle that it will split the base. You'll get 2 congruent triangles on either side. So the thing is, this piece right here has to be equal to this piece, right? And then you know that this is 2 going across here, so 1 and 1, because it's going to split this square right in half. Since that's 2, the collective amount of this and this must both be 1 combined, so they're each 1/2. So you'll have 1/2 there, this is 2, and we know that this is 3 right here. So then this distance is 3. Now what can we do? I'm thinking we have a line here, and you know what this looks an awful lot like? It looks like the first time you ever learned slope. They did triangles, and you've got a rise of 2 over a run of 1/2. That's going to be 4 over 1 as what you're going, which tells us that this part right here is 4 because that's 1 as it shows down here. So I've got 4 there, 2 here, 3 here. I'm looking for half base times height. I currently have 4 plus 2 is 6 plus 3 is 9. So you're going to have 9 over 2 times whatever the base is. The base being the whole side length. Be careful that here you don't do half the base. We already accounted for the half. Be careful with that. Just do the full base. I've made that mistake before. That's why I'm avoiding it now. So then, how am I going to get this piece right here? Again, it's a 4 over 1. So this needs to be something that I would multiply by 4. I just use u. And then you're going to get 3. That's going to be 3/4. So this will be 3/4, this distance here. Now, if you think about it, is 3 divided by 3/4 equal to 4? Just want to verify. Why? It seems logical, but just verify, right? So yes, it is. 3 divided by 3/4 is 3 times 4/3, which is 4. I've got the same rise over run that I want. That means this is 3 over 4 also. I'm going to add these 2 to get 6 over 4, which is 1.5, plus 3 is 4.5, turned into a fraction, 9 over 2. And 9 over 2 squared is 81 over 4. 4 goes into 80 20 times, and you'll have 1/4 left over. We've got answer choice B looking really good at this time. We're going to go on to problem 14. All right, now we will do the fall 2021 AMC 10B problem 14, 12B, problem 11. Una rolls 6 standard 6-sided dice simultaneously and calculates the product of the 6 numbers obtained. So it's a product. What is the probability that the product is divisible by 4? So I will go through with you what I did and even showing you the initial trap answer that I got in my solution process. How I thought about it right then was more careful, got rid of the trap answer and got the correct one. So the first thought was to be divisible by 4, I'm going to need 2 of the rolls to be even. So I'm kind of thinking probability at least 2 are 2, 4, or 6. Okay, and you might have done this too, and you might have got the same trap answer I got. Well, this is the same thing as 1 minus the probability of 1 or 0, 2, 4, 6s. Okay? So let's just do 1 minus, the 0 will be easy. If there's no 2s, 4s, and 6s, it would mean that each die roll was odd, and half of them are odd. So you would just get 1/2 to the 6th power, and because it's half a chance for odd times odd times odd, always 1/2, and that's going to give 1 minus 1 over 64. Then I said, okay, if I had one of 2, 4, and 6, I'd use binomial probability here. So binomial probability is, again, it's n choose k. By now you guys should learn this one. I've gone over it multiple times in multiple videos now. N choose k, probability of success p to the power of k, and failure 1 minus p to the n minus k. Okay, then what? Well, I want one success, which is like 1, 2, 4, or 6. So I said 6 choose 1, which is always going to be just 6. Your chance of success in this case is equal to the chance of failure. So it's really just going to be times 1/2, and you'll want to the first, but again, this is 1/2 to the 5th, combined 1/2 to the 6th. And so 1/2 to the 6th would be 1 over 64, and then you've got 6 times that. So 6 times 1 over 64 is going to be, well, actually it's this. Just leave it like that so that we can subtract. And you'll be super excited because you'll find your answer right here. And if you're not really careful, you'll stick with that answer and you'll go on to the next one because you didn't think about, just double check your work, right? Think about it. Now, after I got my value here, I'm glad that my first answer is here. I checked that first, but that doesn't mean I'm satisfied and think I'm right yet. Right? That just tells me that if this was right, at least the answer is there, so there's a possibility that it's right. Now I'm going to go back and second guess myself because that's happened. I've made mistakes before. I know what it's like. I want to check. Is it really true that if I only have one of these, it will not be divisible by 4? And the answer is no. If you had a 4, the product will be divisible by 4. And so this is actually not an accurate portrayal of what we need. That is the trap answer. This is not it. So then how do we get the right one? Well, I think we can keep the 1 minus 1 over 64 part. That part is true. But now what we actually need is minus the chance that product is divisible by 4. See, we were trying to subtract all the cases where it's not divisible by 4, but we accidentally subtracted some where it is divisible by 4. And we don't want to subtract those because we want to keep those included. So if you don't know, this is also called complementary counting or complementary probability, if you will. If you have at least 2r and 1 or 0r and you add them, the total probability of any event is always 1. So that's why you could add this one to that one to get 1. So if I took this across the equal sign and subtracted from 1, this would have been a viable solution except for the problem with the 4. So now I'm just going to subtract where I only get 1, 2, or 6. That's really what I wanted. And so 2 or 6 then, and then also I can't have a 4. Well, it's kind of like the same thing, but now I want to also subtract. Let's just say it's 0 of those, and then minus the probability of 1, 2, or 6 is how I should have thought of it. So a 2 or a 6 in the product will not be enough to make a multiple of 4 unless there's 2 2s or a 6 and a 2 mixed or 2 6s or something like that. And no 4. Okay, there can't be a 4 either. So 1, 2, or 6, but no 4. Okay, then how do we do that? Well, let's use this binomial probability again and find our success chance. We want our success to have one success. So we're still going to have 6 choose 1. And that success, the chance of it is 1/3. Okay, so there's a 1 in 3 chance that I get a 2 or a 6. Okay, because 2 out of 6, 1 out of 3. But this is the tricky part. We can't just use this straight up. because we don't really want to use 1 minus p. That would mean that you have a 2/3 chance for all the other numbers, but we actually don't want all the other numbers. We want only the odds. So I am taking the basis of this, modifying it to my needs right now, and then going forward in the problem. So I've got a 1/3 chance of getting a 2 or a 6. I need all the rest to be odd. So it's not quite like failure of getting a 2 or a 6. It's more like only having odds. And the chance of an odd is 1/2. I'm going to need how many 1/2s? 5. Okay? So think of it this way. I've got like one number that's 2 or 6, and then I've got odd times an odd, times an odd, times an odd, times an odd, times. And so in the same way, it's a lot like binomial probability. I'm choosing the order of this to occur. Is it the first die roll that's the 2 or the 6, or the second die roll, or the third die roll? That's this 6, choose one. Choose one of the die rolls to be a 2 or a 6, and then times the probability of getting a 2 or a 6, and then times the probability that the rest of them are odd. This is going to work, I believe. 6 times 1/3 is 2. I'm going to have 2 times 1/2 to the 5th. That's 2 over 2 to the 5th, which is 1 over 2 to the 4th. And it's going to be actually 1/16. Again, I don't really want this. It doesn't play well with that. So I'm going to multiply by 4 over 4. It's now 1 minus 1 over 64 minus 4 over 64. So 1 minus 5 over 64 is going to be 59 over 64. I hope you dodged this trap, and if you fell for it, lessons learned. I always try to make sure after I see something I don't feel comfortable just yet, especially as we're getting later in the test. But sometimes it happens even earlier, like sometimes problem 2 from the past or something like that. So always kind of have that feeling of unease. Keep yourself on edge. Be humble. Don't be overconfident. And that's going to allow you to catch when you're maybe getting close to making a mistake or falling for a trap answer. We'll be on to problem 15 and also problem 12 for the AMC 12B. Problem 12 for the AMC 12B, it used a really weird formula. Like I did it in a bashy way, but I also found a formula way to do it. And I feel like the bashy way was really long, and so this was a major time sink for a lot of you. Again, it used a formula that if you knew it, but I've never seen this formula on any AMC test before. I've never seen it come up. So maybe it's been there. I didn't ever come across it in the AOPS books. It might be an intro to number theory. I looked a little bit to see if I could find it, but didn't see it there. Maybe it's hidden in chapter 6 or something. I don't know. But let's get on to the next problems, and on we go. Okay, the fall 2021 AMC 10B problem 15. And if you struggled with this one, let me tell you, I did not have an easy time of it. There was multiple things that I tried before finally finding something that worked. If you ended up skipping this problem, honestly, you really should just not feel bad. It was cleverly disguised a way that you could approach it. And there's so many different things you could do that you've seen done in previous similar problem types that I felt like, I mean, honestly, I could think of about 14 different options off the bat to do for starters. And if you get lucky and you pick the right one in the first couple of different attempts, then maybe you will be able to get this problem quickly, and then you're on to problem 16. But if you got really frustrated on problem 15, I feel ya. I really feel ya. Okay, let's get started on how we should do this. So, in square ABCD, that's this one, points P and Q lie on AD and AB respectively. Segments BP and CQ intersect at right angles at R, with BR equal to 6 and PR equal to 7. What is the area of the square? It really feels like not enough information. Like, did they leave a sentence off or something? No, there's enough. We're going to get it. So the first thing I want to do is, let's call this a variable x. Okay. Then I'm not going to go through my failed attempt ways. Sorry, we don't have time in this video. It would be way too long. So from here, you're going to find BQ. And BQ is going to be the square root of 36 plus x squared. Then what? Well, now we're going to use a small notebook technique. I call it car driving technique, but it has other names like similar triangles. And basically, if you have a right triangle and you drop the altitude, one of the ratios that gets created is A over M equals M over B. In other words, M is the geometric mean of the two pieces of the hypotenuse. And that's what we have right here. We've got a right triangle. And so I can find this length over here by doing x, because it's 90 degrees here, x over 6 equals 6 over whatever this is. And so I'm going to put a question mark or whatever. So x over 6 equals 6 over question mark. And I would like to express that question mark in terms of x. So I'm going to get question mark times x equals 36, and the question mark is going to be equal to 36 over x. Okay, so now we have that. What else do we do? Well, you've also got that this is 30 degrees, or I'm sorry, not 30, but theta. I'm going to call it theta, and I'm going to call this angle here 90 minus theta. And keep in mind that this is 90, and that's why maybe you should mark it, and this is 90 minus theta, and I'm going to call this V. All right, so now what? We've got some similar triangles going on. Namely, because this is 90 degrees, I've got this triangle and this triangle are similar. They've got AA similarity, meaning two angles of one are congruent to two angles of the other, which forces it to be similar. And the ratios I will set up is as follows. Opposite theta is x, but opposite theta in the other one is v. So I will say x over v. Then that will equal opposite 90 minus theta is 6, and opposite 90 minus theta here is AB, which we don't know. We'll have to get that in a second. So we've got 6, and we would like to find the side length of the square, which might help us get it. How could we get that? Let's do it here and make this the new question mark, if you will, or call it y if you want, whatever. So this squared plus this squared has to equal this squared. So I'm going to have 36 squared over x squared plus 36, because that's 6 squared, has to be equal to y, and then y would equal, or y squared, right? So if I say y squared equals, what are we going to do? We're going to square root immediately to get what we want, which is this. Now, you could leave it like that, but seeing as those are both 36s and 36 is a perfect square, maybe we should clean it up and see what happens. Let's multiply by x squared and x squared. Now, you're going to factor out a 36, and so you will have 36 over x squared inside the square root times, and there's still a 36 left here. You're going to have a 36 plus x squared. This is your breadcrumb. This is you realizing that you're on the right path because you have one of those right there. Probably on the right path. It's way too convenient and nice for it not to be. So this is going to factor out 6 over x. And I'm going to erase this and write it here. I don't need this question mark thing anymore. This is going to be 6 over x times, and I'm just going to put the square root. What is the square root? It's that square root. And I really don't want to write the things inside. There was enough calculations in this problem. I know what I mean by that, and that's all I wrote on my paper. So then now what do we have? That's the side of the square. So I'm just going to put that here as 6 over x times that square root. Again, if you have a square root running around in your problem in multiple parts and you already have it written what's inside, just put the square root symbol for yourself. It'll save some time. So now what? We've got, why is this ratio even here? It's the side opposite 90 minus theta. This is this angle. The side opposite is 6. Then I've got in the other triangle 90 minus theta. Its opposite side is AB, which is the same as BC because it's a square. Finally, we do the side opposite 90. In the side opposite 90 in the small triangle, it's the square root. In the side opposite 90 in the big triangle, you have 13. And playing around with this is going to enable us to be able to get it. I think that we don't even need this V here. I think we could just do with this. because maybe we can make an equation that has just x in it, and then we can solve that. Let's go ahead and cross multiply. I'm going to get 13 times 6 equals 6 over x, and then it's going to be the square root times the square root, which means it just poof disappears, and what you have left is 36 plus x squared. By the way, why do I call it car driving technique? You can think of this like a map. Sorry, real quick. You drive over street marked A, you go over street marked M, you do a U-turn back over M and then over B, and as you drive over the streets, you write them down. So I think of it like a car driving on the map, and that's how that works. So over here now, we're going to divide by 6, and then you're going to multiply by x, and you're going to have 13x equals 36 plus x squared, and you're now going to move the 13x over, so I've got x squared minus 13x plus 36 is equal to 0. Now, first that comes to mind is 9 and 4. So if you do x minus 9 times x minus 4, that will mean that x could equal 9 or 4. All right, but is there any reason why it might not be able to be one of those? If we try 9, I think something doesn't work out. I forget what. Let me see if we can figure it out real quick. Oh, I probably know. What's 81 plus 36? If you do 81 plus 36, you're going to get 117, root 117. But if you put 9 here, you're going to get 81 plus 36. That does work out. Does the 4 work out? Let's check. 4 squared plus 6 squared. Of course it would be 4 squared plus that would, of course that would work out. Where would it not work? If I had 4 over 6, oh, I know. It's probably because if you put, this is the bigger piece clearly. So then x would need to be 4 and this would need to be 9. And if x was 9, then this piece would be 4. So I think we're going to have it to where x is 4. So now if I plug in 4 to my side of my square, remember the side of your square is this, okay? Then you're going to multiply 6 over x squared times 36 plus x squared. Then now if I make this 4, you're going to have 3 over 2 squared. And maybe it works with both cases. We'll check it in a second. 3 over 2, because it's 6 over 4, which is 3 over 2 squared, times, again, if I let this be 4, it's 16 plus 36, which is 52. Now, I happen to know that 2 squared is 4, and it's going to go into 52 13 times, so you'll cancel to get 13. 9 times 13, I think we just did that. I don't know. 90 plus 27, it's 117. Answer choice D. Out of curiosity, does the 9 actually work? Let me just check it. I would get 6 squared to be 2/3 squared, but you would have times 117. And I don't see how that's going to also give 117. 36 plus 81. I don't think that works. Yeah, I'd have to think about why that's not going to play out. I think it's just the appearance of it. I went with the 4. Maybe with the V it would have been, something could have come out with that. We could have solved for V to see what you get. I forget the reason off the top of my head right now, but I can't spend any more time filming on these problems. So I know that this works because the 4 is there. What would you get if you plugged the 9 in though? Let's just check it out real quick. So you would know 52, it's not even up there as an answer. So 2/3 would give you 4/9 times 117, and 9 goes into 117 13 times. As we already said, 9 times 13 is 117. So then 4 times 13 would be 52, and you don't see that up there. So even if somehow it was supposed to work, it's not among the answers. We're going to go on to the next. Okay, I just remembered why it doesn't work. It's hard to remember every single step in the problem because I'm not looking at my notes as I go. If you were to find this value right here, let me go back and do that real quick. the AQ part. If you were to find AQ, you just might be curious why it doesn't work. AQ would equal this side minus this. So you would have 6x times that square root minus the square root. Now if you factored out the square root, you would have 6 over x minus 1. If you put a 9 here, you're getting a negative value for this. That doesn't work, and that's why 9 is not going to be a viable value. And it has to be 4, which gives you a value more than 1. And then when you subtract, it's positive. Now we're really done, and we're moving on.